Tech Nuggets, VPN, Open VPN, site to site. We're going to talk a little about what a VPN is, virtual private network, why we might want to use a VPN, when is very similar to why, although not always quite the same way, which is why I listed out a little differently. There's a couple different types of VPNs. There's client VPNs and there's site-to-site VPNs. We're going to talk a little about that, and we'll get into the details of some of the meat and potatoes of what's going to go on with actually setting up a site-to-site open VPN. So a virtual private network is a way of linking two devices together where some or all, depending on the kind of VPN that you set up, of the traffic for the device goes into an encrypted tunnel that gets shot over the internet to the tunnel head, which is receiving packets from the other end of the tunnel. There's two ends of the tunnel and one's sending to the other, where the packets will show up and they will appear to show up as if they're on the same network. So in that way, we can have remote devices using an encrypted tunnel to become part of our network as if they were there. To the client device, it may appear, or the client device may just simply believe that I'm on that network, when in reality, I'm at a coffee shop and I VPN'd into work, and that way I can access sensitive information or something like that. It gives me a level of encryption and redirection of my traffic. And it can be some or all of my traffic. We can do split VPNs where only specific subnets go off that direction, or we can set it up in such a way that all traffic goes off that direction. And there's all sorts of trade-offs and balances that go with that. Sometimes you want one, sometimes you want the other. It just kind of depends. We most often use VPNs in a site-to-site capacity when we've got a remote office and we've got a central office and we need to link them together, but we're going to use the real wild internet to do that. And so we can do a site-to-site connection where both of them have internet connections from our ISP, but the ISP is not going to do any kind of magic to put us all on the same VLAN or something like that. It's going to just use the internet to link us together. So we're going to use two different routers. In our case, we're going to use Voyos, and we're going to set up a pre-shared key to allow them to have a secret key that they'll use to encrypt the traffic back and forth, and we'll do a site-to-site link. And we'll generate this pre-shared key, PSK, once on one of the routers, and then we'll need to copy it to the other router, or routers plural, if we were to use it for multiple links. Usually we have one key per link, and as you can see here, it says OpenVPN-1. So we're going to generate it on Voyos 1, and then we're going to copy that key, which is really about 30 lines of text, although it's generated special kind of text, and we can copy and paste it into the right file and set the rights on the file, and it'll work just fine. And as we go through and set it up, that won't be a big problem. This kind of site-to-site link does not rely on getting certificates from a certificate store or anything like that. It's in terms of encryption, it's very similar to the pre-shared key you might use on your Wi-Fi, where you know it and you can give it to other people. In this case, the pre-shared key is about 50 lines of moderate gibberish, so you couldn't just rattle it off like you do your Wi-Fi password. Building this is a complicated little beast, and I heavily use this document and that I list here to set up the site-to-site. I also use Professor Saunders, who is much more knowledgeable than I am at setting up VPNs, and he was a great help. So the basics of what we're looking at here when we do this, we're going to lay out four networks in our demo, and I wanted to talk to them a little ahead of time. So we've got one network that's our VPN network, and it's strictly going to be used to connect the two routers together via the VPN. We'll have three other internal networks, and our 172 addresses are private address space. They're RFC 1918 space, so they're non-routable. But we can use it over the VPN because it's staying, the VPN will keep it all inside us. So you see I've got network 1, 2, and 3 set up. They're all /24s, so they're kind of easy to understand and see. Our public addresses, if we're going to use the internet, I realize a 10.101 address isn't public, but for our particular demonstration environment, it will be treated as such. We'll also have a 132.235 address that will be set up. And you can see I have Voyos 1 and Voyos 2, and those are the ETH0 WAN side parts for Voyos. So those will be the public addresses. They should be able to ping each other and do all that other kind of stuff. It's really important to note that these addresses, when I think about them, they come in pairs. So when we set it up over the VPN, we need to think of 10.101.80.1 as the public version and 172.30.128.254 as the private version of the same thing. And the 172 addresses on our VPNs are going to turn up as virtual interfaces. So in the 132.235.160.222, we also have an IP address that gets associated with that interface, and it'll be a virtual interface or a virtual IP address on that, and that's 172.30.128.1. Now note, the 172 addresses are on the same network. They come out of the VPN net, and that should begin to tell you, oh wait, that's the linking network between the two routers. It is, and we're gonna ride the VPN between that network so that we can get our other networks to work. And as we think about one IP is the real IP address and the other one is part of the VPN tunnel. The 172 addresses are part of the VPN tunnel. At the end of this, we're going to have to set up route entries so that each router can see traffic. When it sees traffic, it knows, oh yeah, I need to shove that over the VPN. So just setting it up won't get you very far if you don't put the route entries in to say, hey, if I see traffic for the far end, send it to the far end's 172 address. Oh, and that way the traffic will route back and forth. And we can play some head games with things like that. This is where we get into that discussion of, do I want all my traffic to go over there, or do I just want some of my traffic to go over there? And depending on the route entries that we set up, we could shove all the traffic through the VPN to the central office and let everything go out through the internet feed there. That would make our clients look to the internet, to the rest of the wild, wild world, like we're at the home office, when in fact, we're at the remote site. And so we can do some of those things and hide in our VPN. And that's what that's for. So let's go on to our practical demo. I've got a GNS3 setup where we'll look at it and go through the different setups and how that works and that kind of thing. All right, so here you can see I've got my GNS3 set up. I've got my cloud here that has 2 connections off it to 2 different VoIOSes. ENS 160 in this case is my 10.101 network, and my ENS 192 is the 132.235.160 network. And I've got VoIOS, and then I've got a VPCS set up on each of them. And I've done a little pre-configuring so that we can get the ball rolling and that kind of thing and see what's going on. So the first thing we're going to want to do is generate our key. So I went to VoIOS 1. I've actually done some of this before, so we're going to generate a second key just to see how it's done. And we're going to do a generate, and we're going to say open VPN, and we're going to say key, and it wants a file name. So where do I put this silly thing? And normally we would say we would put it in config and auth, and we're going to call ours OpenVPN-2 since I already have a -1, and we'll actually go and use one in the config later. I'm just going to generate you one to show you what it looks like. So there we go. It's been generated. It's really fairly unexciting in that respect. Let's go have a look at the key. When it generates the key, it sets the rights on the key as root. So our account ITS class can't see it. So we're going to have to sudo to it, which is fairly easy. And we're going to use more, which is basically just feed me a file and I'll show it to you a page at a time. We could probably use cat as well, which would work just as well. Auth and OpenVPN. You can see I have 1 and 2. I'm going to say 2 because that's the one we just generated. And it's going to spit out a page of text. Hashtags, number signs, whatever you want to call them, are comments, and you can see it says begin and end, and then there's gibberish in between. This is a key. It's a 2048-bit key. It's fairly strong, at least at the current level of technology. As processors get more powerful, of course, we need bigger and bigger keys. It used to be 512 bits was big, and dinosaurs roamed the earth. What can I tell you? So our current configuration is going to use key number 1, but what we may need to do is copy and paste that key, and we can do that by highlighting it and saying copy, and we can open a text editor. Oh, look at that, text editor. And we can paste our key into it. And we can go to VoIOS 2, and we can go to config, auth, and we're allowed into that folder, and we can see the key, right? There's our key. I did an ls-al, and we can see that our OpenVPN 1 key that I've already used is here and is owned by root. So I wouldn't be able to edit it. And we're going to create a new key. Nano OpenVPN-2 key. It's going to open a new file. And all I'm really going to do is paste it in. And, right, it's all there. Hit Control-X and save it. Now, if you look now, you'll see that OpenVPN-2 key is not owned by root. It's owned by ITS class, which is not what we want. So we need to change the ownership on that by saying sudo ch own. Oops, own. And we need to say who's going to own it. I don't know why it's ch. Oh, change ownership, ch. And then we're going to say OpenVPN-2 key. And now when we look, it's owned by root. So we've generated a key. We've copied the key to both routers. That way, both of them have to have it. And we've changed the rights on it. All right. So let's dig in a little to the config that's going on in this setup, so that we can understand a little bit more how that works. So I'm going to open up the one for Voyos 1, and we'll go through the different options and how they get set up and stuff like that. So we'll need to go into config mode. The easiest way when we set things up, most of the work is going to be done in set interfaces. And if we do a tab here, whoops, we're going to see that one of the options right up here is OpenVPN. So most of the commands, except the route commands, are going to be set up using this OpenVPN options. And what do we need to set? Well, we're going to call it vTun1. If you had multiple tunnels, you'd have vTun2 and 3 and 4. And the first time you issue that, it will create that kind of thing. So vTun1. And again, if we do some tab, we can see that there's a whole variety of different options. Setting IP addresses and bridges and all sorts of crazy stuff. Let's have a look at it in our config. I think it'll be a little easier to understand that way. I've already done the number of lines, and it might be easier to see it there. So let's just do a show interfaces, and we'll do the OpenVPN, and that'll just show us the part that we need to see. And I'll show it to you in context with the larger piece here. And you can see I've issued the commands to, starting at the top here, we can see I've set the local address. Remember I said they came in pairs? So we can see that we set the local address for the tunnel. vTun1's address is set to 30.128 or 172.30.128.254. So that's the virtual interface that's going to live here on ETH0. That's the tunnel interface on ETH0. And we're going to attach it to its quote real IP address of 10.101.80.1 by saying the local host IP address. We're going to talk about the local port that it's going to use, and we're going to talk about the site type that the mode type that we're going to want. This is not a client VPN, it's a site to site. It's also a persistent tunnel, which means come up and be ready to make a connection whenever the interface comes up. So it's always there, it's always going to be on. We can talk about the IP address, or the protocol that we're going to use. It's a UDP tunnel. There are other types of tunnels you can make. We can make some TCP tunnels. UDP tunnels are often the ones that are used. We need to define what the other end of the tunnel looks like. So what am I looking for when I go to the other end? What's its remote end going to look like? So we can see 172.30.128.1, and that's Voyos 2's interior tunnel IP address. Remember I said they came in pairs? We also need to know its public address. So when I'm sending packets to the other end, where am I sending them to? Well, I'm sending them to 160.222. And again, we have a remote port, so that way we know IP and port that we're sending it to. Where is it coming from at 10.101.80.1? Where is it going to? And then, of course, we have to list our shared secret file. And you can see I've got OpenVPN1 key here that I listed earlier. When we go look at the interfaces themselves, we can see that it's been set up, right? I set up ETH1 with 254. So that IP address exists, and it's assigned to ETH1. That's our interior network. So that's not part of our tunnel. That's for VPCS network to be connected to. But the only address that shows up on ETH0 is 80.1. And that's because the other interface is a tunnel interface. So if we want to see what the run show interfaces, what's it seeing on its interface list, we can do a run show interfaces, and we can see that the physical interface got, our public address, which we expected, but our tunnel address is also listed in here under vTun1. So our virtual interface for the tunnel is created, but it's not created in the same way. It's created as part of the tunnel. If we look at Voyos 2, we'll see the exact same thing going on. We go into config, we go into interfaces, we'll see that it's got 162.2.2 on ETH0, right? That's the public side out here, but we have a different network on the inside. We've got 131.254, that's for VPCS to connect in here, but we don't see any of the tunnel stuff. Well, tunnel's listed on OpenVPN tunnel, and we can see that we've given it a different address here. We're .1 on this side, and the other side was .254. And you can see in this case, the IP addresses, the pairs are used in the opposite way. So when we look at it from the other direction, you're standing on the other end of the tunnel, you've got to think about it that way. But it's using the same key. And again, when I do a run, show, interfaces, I'm going to see the tunnel address that's set up. The only thing that's going to see the tunnel are people on the inside of the network. And what this allows us to do is use the tunnel to encrypt and redirect. I talked earlier about how we'd have to set up the routing, which is really important because without setting up the routing, the tunnel will exist, but nothing will use it because we won't have told it to route any packets over the tunnel. So we can have a tunnel that does nothing. It's a little silly, but it is possible. And so, we're going to do run show IP route, which will show us our route table. And we can see in here, I've set up 2 routes, and they even say they go over vTun1. They'll be able to tell that. And I've set up 2 networks to do, or 2 configs to do that. And if we say config, show, we can come down here into protocol static, and you can see I've set it up. So it will know to ship traffic for 172.30.131.0/24, which is our network for our Voyos 2 side, and it will ship it to this IP address. Now remember, the VPN tunnel is a third network. That's the 172.30.128. Voyos 1 is .1. I'm sorry, Voyos 1 is .254. I apologize. Voyos 2 is .1 in this network. So we're telling it, hey, if you see traffic for this, ship it there. That's standard routing that we've done, in lots of other tech nuggets. So when we start doing that kind of stuff, the packets will then be forced over the VPN, which is what we want. And when we do the same thing here, we can look, run, show, route, and you'll see I've got, again, vTun networks. I've got those kind of things set up. And if we look at the route entries for how we do routing, I've got one set up. So anything headed for 128.0/17, which is everything, right? Anything that's part of the 172.30.128.0, it's huge. It's a route aggregated route that's enormous and takes all of it. And it'll ship it all back to Voyos 1, which is 172.30.128.254 is our tunnel address on Voyos 1. So let's go take a look and see how that works with our VPCSs. So I've got VPCS 1 and VPCS 2 that I've already set up. And you can see I went and they have IP addresses, right? They're on their respective networks, which they should be. They're in 129, which is the network down here. And they are in 131, which is the network down here. And when I say things like, hey, ping the other person, 172.30.131.50. Times out and dies on me. Oh, nope, it just took a minute for the tunnel to come up. It sometimes takes the router just a little bit. I thought it was going to die on me. And those can take a little bit. Sometimes the first couple packets don't go so well. So you have to be a little patient with it. And let's see, where we're 30.129.50. Right? Did I get that right? Yeah. Once the tunnel's set up, apparently the first couple things get lost and then everything's okay. So let's do a little packet sniffing and see what this looks like. So we're going to set up 3 different sniffs. We're going to set up one sniff here at PC1, which is going to be the machine that's pinging. We're going to set up a second sniff here on ENS on this link right here to see the encrypted traffic, and then we'll set up a third one here on PC2 to see the ping packets pop out. Now, we learned the hard way that pinging here on ENS 160, because it's such a busy network, tends to make GNS 3 sort of turn over and die. So would stay away from sniffing on that link. It's a very noisy network and tends to overwhelm GNS 3's ability to capture traffic. But the 192 network is very quiet and should work just fine. Getting the sniff set up does not happen instantaneously, so we will see traffic that is not necessarily from what's going on. The link is already set up, so there's occasionally a little traffic that blips over it, and that'll kind of be the thing that happens. So we're going to click Start Capture, and it should start a copy of Wireshark. There we go. That's for that one. We'll start a capture here. Sometimes it puts the little magnifying glass in, and sometimes it does not. You can see it's quite noisy here, and you can't always tell. Sometimes you have to right-click on it to see if it's already capturing or not. Capturing can be very network intensive and very CPU and RAM intensive, so can kind of drive the machine crazy. Remember, at the top it will always tell you Voice 2 Ethernet 1 to PC2 Ethernet 0, so it'll tell you what you're sniffing. Right, I got one magnifying glass. Maybe it's not far enough away. Apparently we didn't do our diagram the right way. So there you go. Now you can see it a little bit better, and you can right-click on it, say Stop Capture or Start Wireshark if you've stopped Wireshark. All right, so in this case, we'll be able to see 3 different things, and we'll make our Wiresharks a little smaller, see what's going on. As you can see, our VPCS networks are quite quiet. All right, so we'll set up our ping, and we can see it's showing up and going across here. Tunnel pops up. It takes a little bit. We'll run it one more time just to generate a little bit more data. And we can see it's going back and forth and stopping and that kind of thing. All right, we can stop our captures now. That way we won't drive the machine totally berserk. I've not found GNS 3 to be terribly resilient when it comes to that kind of thing. But we can go look. One of the things that'll be easy to filter on here, we'll want to put in an IP address filter, and I've done one of these already, so that I can filter on just my traffic, either to or from Voice 1's public address. So what we can see here is that there's a whole bunch of UDP traffic. It's going back and forth. It was generated at about the same time. If you were to run it all at the same time, you would see one for one, a packet here generates a packet over there. We can see it going back and forth. These are generating and receiving, and we don't really see any outside world stuff. But that's what we expect to see. We don't really expect to be able to see anything. It's encrypted traffic. You can look down in here and see that it's all encrypted. It's just going to be garbage. You're not going to see it. It's a packet inside a packet. So that's why we call it, oftentimes it's tunneled or redirected. Well, I hope you've enjoyed our VPN Tech Nugget for site-to-site OpenVPN, and we'll see you for the next Tech Nugget.